Okay, now we're going to put our skills that we learned in the last lesson with the z-scores and the z-score tables to work in terms of actually applying it to problems and problem solving. So, for the first example, a light bulb manufacturer produces 35,000 light bulbs. From past data, the lifetimes of the bulbs are normally distributed with a mean of 900 hours and a standard deviation of 50 hours. Predict the percentage of light bulbs that will last between 825 and 875 hours. Well, right away, I can find the pertinent information. So we know we have 900 hours, we know we have a standard deviation of 50 hours. There's my mu, there's my sigma. If I'm looking for between 825 and 875 hours, well, they're both going to be below what my average is or my mu is, and I can say that this would be at 825 and this would be at 875, and I know that I'm trying to find for the area in between those points. I'm probably also going to state that there's my average of 900 right in the center. Now, if I am trying to find what this is going to be, well, the first thing is I need to figure out what the z-scores are going to be. So I'm going to state that the z-score at 825 is going to equal, well, my z-score was always x minus mu divided by sigma, which means that in this case, I'm looking for 825 minus 900 divided by 50. My z-score for 825 is going to equal negative 1.5, or 1.50 if I want to go to the hundredth, because that's what my table says. For 875, I'm going to say that I have 875 minus 900 divided by 50. The z-score at 875 is going to equal negative 0.5, or 0.50, because my table goes to the hundredth. So what I'm really looking for in this case is I'm looking for my probability in between negative 1.50, which is less than or equal to my z-score, which is less than or equal to negative 0.50. What's my probability in between those 2 points? I'm going to solve this by using my area for the right one minus my area for the left one. Then I need to go to my z-score chart, and I'm going to say, okay, so what is the area at negative 0.50? And I'm going to get 0.3085. What's my area at negative 1.50? That's going to be 0.0668. And the difference between those two is going to be 0.2417. If it wants us to state the percentage, I'm just going to multiply that answer by 100 and say it's going to be 24.17%. The second part says, how many of the 35,000 light bulbs would you expect to last between this? Well, if it's going to be 24.17%, Then, to solve that, I'm going to take my 35,000 and I'm going to multiply that by 24.17%, or as a number, 0.2417. Multiply it by the percentage, and it's going to tell me what the actual number is. In this case, it's going to be 8,460 bulbs. If it asks us to determine the probability that a bulb selected at random will last less than 920 hours, well, then I know that if this point is 900, then 920 is going to be a little ways past that. So I'm going to do basically the same thing I did in the last case. I'm going to state that my z-score for 920 is going to equal 920 minus 900 over 50. My z-score at 920 is going to equal 0.40. And now my probability is just going to be the probability for the z-score that is going to be less than 0.40, which is going to equal the area under 0.40, which is going to be 0.6554. If they asked for this as a percentage, it would be 65.54%. For example 2, a study showed that the mean duration of a certain strain of flu virus was 12 days, with a standard deviation of 3 days. If the data is normally distributed and you caught the strain of the flu virus, determine the probability to the nearest hundredth that it would last either longer than 17 days or between 13 and 15 days. Well, first I'm going to start by saying that if my mu was 12 days, I can start the chart on both sides with 12 in the middle. In the first case, it's asking for if it is longer than 17 days. So I'm going to state, well, if I had 17 up here, then I'm solving for the area that's above that. If it's between 13 and 15 days, well, 13 days would be more than 12. 15 days is going to be more than that. And I'd be solving for the area in between here. Now, the first thing we need to solve for is the z-scores. So I'm going to say that the z-score at 17 is going to equal 17 minus 12 divided by sigma, which in this case is 3. The z-score is going to approximate to 1.67. If I'm solving for the area above that z-score, then I'm going to say that if a probability of when the z-score is greater than 1.67, then that is going to equal the total area to the left, which would be 1 minus the area to the left of 1 when it's 1.67, which would be 1.67. Which means that this is going to be 1 minus, well, the area at 1.67 is going to be 0.9525. Which means that this would equal 0.0475. If it wants it to the nearest hundredth, I'm going to say 0.05 is going to be the area above there, or there is a 5% chance. For the second one, I'm going to start by solving those z-scores again. So I'm going to say the z-score at 13, oh sorry, not probability, z-score, is going to equal 13 minus 12 divided by 3, which would approximate to 0.33 when I round to the nearest hundredth. If I'm doing the z-score at 15, that's going to be 15 minus 12 divided by 3, which means I have a z-score of 1.00 if I'm going to the nearest hundredth. Now I can state that the probability of it being between these 2 points to my z-scores, the probability of it being between 0.33, which would be less than z, which would be less than 1.00, would be equal to the area of the one on the right, 1.00, minus the area of the one on the left, 0.33, which would be 0.8413 minus 0.6293, or 0.2120, and this has a 0.21 or 21% chance of occurring.